Welcome to this webinar. Good morning and good afternoon. Good morning to the US, good afternoon to Germany, to Europe. I'm happy, together with Darshan, to present to you today the webinar on managing design and CAE model changes in the simulation process. We have a very condensed, we have a very many topics we want to cover, so let me jump directly into the agenda. What I will do up front is I will give you a short presentation and positioning of the SPDM solution, how we see it fit into the overall product lifecycle management. With that short overview and positioning, I will then motivate the challenges we see for managing design and CAE models. And this is PowerPoint, and then we will have demonstrations where we will show you the process in SimManager of how we propose to manage design models used in the simulation process, how changes in the design should be managed in the simulation process, and how changes of the model in the CAE world should be managed. And then after, it's going to be a three-part demonstration. After that, we're going to have a conclusion. So let me get started with the positioning. Clearly, what is simulation? Simulation is all about answering to questions in the development process. And to formulate questions in the development process of any type of product, essentially what you need to articulate a question, you need some product requirements and objectives, and you need some sort of definition of the product itself. When you have those two ingredients, which are managed in enterprise systems, you can then formulate a question, which can then be passed to the engineers, to the analysts, and they then in their environment answer to those questions and feed them back either in form of reports and results or in form of optimized designs back into the development process. The goal of SimManager and our simulation data and process management environment is really to provide to the analyst an environment, a framework to manage those processes of consistently and repeatable and auditable answering to questions out of the PLM and to orchestrate the communication back into the PLM. So, with this short introduction, we see SimManager as really being a component of the overall PLM, but not so much as an data model extension component, but much more as a question answering machine for the overall product development process. Our functions in this role is to really manage the work in progress data that an analyst generates by conducting his simulations and establishing clear, consistent auditing of how that data was created and which reports were generated and how that is moved back. And I will be pointing this out throughout the presentation today. Also, we not only manage the data, but we also manage as data objects the methods and tools so that you can enforce or you can guide the simulation process and make sure that the right processes, templates, scripts are used to exercise specific actions like a meshing, like a simulation, like a reporting, like a post-processing. And really make sure that for specific projects, the best practices processes are followed so that there's a high consistency in the answers as they are communicated back into the PLM. And then, of course, SimManager is also an enterprise system to handle the whole communication, both into the process and back into the PLM. SimManager is an enterprise product. So with this short positioning, let me just have one slide on SimManager itself before we then dive into the topic of this webinar. So SimManager is an enterprise data and simulation data and process management system. It has three key functional areas. It has the functional block of managing data. It has the block of managing workflows, orchestrating flows, and then also handling processes within the simulation world. Key is that all the data generated, all the methods and tools are on centralized servers, and you have full accessibility to those data. So let me come now to the topic of this webinar. It's about design and CAE model management. And what are the challenges in this area? So the first challenge we see is, how do we manage versions of design and versions of CAE models? You know that design, you always have incremental new versions, new alternatives, new iterations, new revisions of your design and of the assemblies. And on the CAE side, you have CAE models being generated from those design models. You have internal CAE iterations where you are modifying, where you are optimizing your models. And you also have different representations of your model if you're running a CFD simulation, if you're running a multi-body simulation, if you're running a NASTRUN simulation, if you're running a crash simulation, etc., etc. So keeping track of all this, organizing it in a logical manner so that the analyst finds its way through it and doesn't lose oversight is crucial. The second point is, and it's something I pointed out in the early part, is as you generate data in the simulation process, we need a systematic tracking and tracing of what data is used. So that as when you're doing a simulation, you know exactly, I had that mesh model, which was derived from this design state, so that we have always a consistent auditing and tracing of the data forth and back. What models did I use? And also when you have models, where in which simulation was I used and then assembled into? Another part which we are noticing as we are talking to our customers is managing the data, tracking and tracing the data is mission critical. But something which analysts really want to do to really get an advantage is they want to have fast and immediate abilities to compare the data. As new designs come in, the first question analyst is going to ask is what changed? If he has a mesh and he has a geometry coming from design, he wants to see what was the defeaturization? Do I actually need to remesh my part? Is this design change so significant that I need to do a remeshing, a remodeling of my simulation model? Or is it so insignificant that I can continue working with my models? And we were going to show in the demonstration how and which means we can provide for the analyst to have this transparency in understanding exactly the models, how they relate and how they compare, how they differ from each other. And the fourth point, the fourth challenge area we are presenting is you need governance in the modeling process. We are seeing at many customer sites that meshing is offshored, meshing is done by contracting companies, etc., etc. So you need to kind of like have an orchestration to make sure to manage the process, manage distributed teams throughout the globe. So what we're also going to show is the concept of work requests and how we can orchestrate the flow of generating simulation models. With that short introduction and motivating of the challenges, I want to really go now into the section of showing you actual demonstration of the system and of an implementation of all the key situations. So we will have 3 parts of the demonstration. The first part is where we are showing you just in SimManager some navigation on a baseline set of data and simulation results so that you get familiarized with SimManager, with how the data is presented. Then we have a demo where we are actually playing through a scenario of a design change happening in the PDM world, and then how does that funnel through the whole system. In the third part of the presentation, we are in a third demonstration, what we're going to do is we're going to actually show how do you handle, for instance, now that you internally in the simulation world change a CAE model. With this, let me explain you the demonstration part 1, just how the data is organized in SimManager. Something we notice in simulation data and process management is for an analyst, a clear anchor object is always an input deck, particularly in the FEM world, finite element world. Then from that input deck, what you will see in the demonstration is how you can navigate to the results and to the CAE results. So how you can navigate in the simulation data and how you then can aggregate those simulation data into reports. And we're going to show you also to the left how you can navigate from your input deck to the CAE models, to the meshes, to the include files which were used in the input deck. And from there, how you can navigate to the design models, to the design assemblies or modules. Okay. The demonstration, we're going to use a common model. It's the neon car model. This is going to be used as a model throughout the demonstration. Something which I do want to point out right here is we have in the CAE world for this demonstration used a common, I would call it, two-level assembly structure. Typically what we see, particularly in the automotive industry, is if you have an input deck on the finite element side, basically it's constituted out of modules like the driveline, the body in white modules, and then those modules are assembled out of individual parts, component parts. And so this is the module structure we will have reflected right here in this demonstration. With this, I will start the first presentation and hand control to Darshan.
Yes, thank you, Michael, and hello, everybody. Let's now go over the first part of the demonstration. This part talks about data navigation. So if you have the neon model that was described in the previous slide was already, the baseline of that model was already simulated using SimManager, and the analyst now wants to look at the data that is available inside SimManager system. So first thing he does is he logs in with his credentials. SimManager is a web-based system, so you have an account and a profile associated. He lands on the home page. The first widget that he sees is my input deck widget, which takes him to the input deck SOD, single object display, or the detailed view of that input deck. So with this my input deck widget, he can very quickly navigate to the input deck that he's interested in. He sees a detailed view or a single object display of an object type called safety input deck. This view that you see here is completely configurable based upon the preferences and practices in an organization. This view shows a lot of metadata like the owner and the release level and the status of this input deck, the scenarios associated with this input deck, and so on and so forth. In addition to that, you will notice here that on right-hand side column, there is a lot of CAE metadata which was automatically extracted by SimManager and is presented in HTML format. A lightweight viewer, in this case Vcolab, is also presented in this view where the analyst can take a look at various parts of the vehicle. Results and key results are accessible right there on the detailed view of this input deck. Going to the detailed view of the result, we see since this is a full frontal crash, there are a lot of result files, P3 plot files associated, which are available right here as links. And in addition to that, in the Vcolab widget, the lightweight viewer widget, all the simulation capabilities or simulation operations can also be performed, like fringe plots, animations, and so on and so forth. These operations can also be performed in a full screen mode. So eliminating the, let's say virtually eliminating the requirement for the analyst to download the input deck from the central server and then open his preprocessor and or the post processor in this case and perform the operation. In addition to the animation, what you see here is SimManager automatically during the simulation operation extracted certain hotspots and created annotations which are readily viewable on the detailed view of this input set. Similarly, there were a lot of key results extracted automatically in the background on an HPC, which are presented here. Those include the curves and images and movies and so on and so forth. So, for example, if the analyst wants to navigate through all the different curves that were extracted or all the different images that were extracted during the simulation, to orient himself about this simulation and inform himself better about the simulation, that can be done easily using the audit trail viewer functionality, which you are seeing on the top half of the screen. The movies which were extracted can be played using the links available on the audit trail viewer. To the left hand side of the safety input deck, which is the anchor object of this audit trail viewer, you can see all the subsystems or the modules, as Michael mentioned, listed here. Corresponding design modules are also shown in context of the mesh modules. These mesh modules are made of or assembled from various different mesh parts, which can be seen here or right on this view. So this gives you a complete audit trail. Another way of looking at the data is the analyst can go to the geometry tree and he can see that the components are ordered in a tree format with a hierarchical assembly. He can choose to go to one of the design modules, for example, in this case, the hood module, and you see here the metadata extracted is also available for the CAD parts, the geometry and the CAD geometry, and including parts and assembly. Including the material properties as well. Going back to the pedigree view, you can see here that the comparison report or the simulation report is also accessible from the same view. This study focuses on hood and bumper analysis. So you see that there are a couple of frame plots of hood and bumper, and associated energy curves are also included in this report.
So this was the first demonstration just to familiarize, navigate in the data to the left, to the right, and see the audit trail view and how we can navigate in the system. So now we're gonna go to the second part of the demonstration. This is now, we have a baseline V1 model in the system, which is based on a design V2.7 from the PDM system. What we're now going to do is we're going to simulate a situation where the PDM system imports a new design of the hood, of one module, not even of the whole assembly, but of one module. And it's the design 4.9. What happens right here, the design, this module, the hood module, is comprised of many parts, or multiple, can be comprised of multiple parts. As it imports it, SimManager realizes which parts are new and which parts are actually didn't change and which are still the same as the V2.7. So as the hood is built up, the new V4.9 hood is built up, it automatically recognizes which design models, which parts of the hood of the assembly parts have changed and which parts are similar to the V2.7 design. That's going to be demonstrated. Then we're going to simulate an assembly process, a batch assembly process, generating a new mesh model from the design module of the hood. Then we're going to use the simulation generator capabilities to assemble a new input deck and run a new simulation. And then finally say, okay, now we want to compare the neon V1 with V2. Something I do want to notice, or I do want to mention right here, is on nomenclature and version numbering. We very intentionally in this demo separated the version numbering of the design models, which is defined by the PDM system, from the version numbering which are you using internally in the simulation world. What we noticed is that most of the simulation departments have their own versioning and number schemes, which is not 100%, which is not directly linked to the numbering schemes which is used in the design world. And this is something we have reflected right here in this demonstration. So with this, Darshan, I think you still have control. You can click and go into the second part of the demo.
So this time the user logs onto the system again, and what he notices is on the right-hand top under My Work Request widget, he sees a work request that was created by someone else and assigned to our analyst. As you can see here on the detailed view of this work request, there are certain tasks, and there is a creator, in this case Molly the manager, created this work request and assigned to Andrew the analyst. There was a standard operating procedure which was already defined in this organization, like most other organizations, and that's this process. So the first step takes to the PDM system. In this case, we simulated a PDM system, a dummy PDM system, but SimManager really integrates with all the PDM systems in the world, and we do have a lot of customers integrating with various different PDM systems. So the next version of the CAD is made available to the analyst via PDM. He imports the CAD into SimManager for downstream processing. So clicking on the submit button takes him to the work request view again, and you notice here that the icon now changes to green, which is an indication of the work for this particular task is complete. Refreshing the view, the analyst can see that under the import revised CAD action, there are few new objects created, and it's visible here that the bumper and the hood went from 2.7 to 4.9, and because of that the full vehicle went to the revision 4.9. So the first thing that comes to anybody's mind is, okay, but what are these changes? So let's say analyst wants to browse through the structure of the two assemblies, and he wants to very quickly compare or visually compare the two different versions of the hood. How can he do that? Analyst will navigate to the contents of the project, select the design modules of the interest, and then he will click or initiate the diff model procedure in SimManager. This invokes a vCollab based model comparison on the client computer via a CAE mechanism of SimManager which works on Java Web Start. You will notice here that the comparison view was already pre-configured by SimManager, so as soon as vCollab opens, the designer can notice the differences between the two versions of CAD. You see that there are some differences in the rib area, and there are some differences with one of the holes. So these are the two differences between the two versions of the CAD. These can be explored more by using the model tree or the navigation functionalities of the viewer itself. So analyst understands what's going on between these two versions. He takes a call that meshing needs to be performed again on the new version of the CAD. So the next step in this work request is meshing. In this case, analyst or the methods expert of his organization has integrated a fully automated batch mesher. But there could be really quite a few different ways in which the mesh is imported. We are going to see one of those different ways in the following demonstration, which is you do the work outside of SimManager and you want to import the mesh inside SimManager. And Michael will touch upon what other options exist in this area. So the meshing step is now complete. All the new CAD files that were received from PDM have been meshed and are ready to be used in the simulation. The next step is to create the simulation variant. So the analyst will create the variant of the vehicle Neon V2 in this case, which will correspond to the second design iteration. He selects that variant and goes to simulation generator, which is a tool in SimManager which helps in setting up load cases and the product structure definition in a very nice and convenient way. He selects V2 of the hood and bumper and hits submit, which takes him to assemble and simulate dialog, where he can enter more parameters like, for example, number of CPUs, memory, etc., solver parameters and other parameters. The manager then fires the simulation. First step of the simulation is to assemble. The manager clearly shows which commands are being used for assembling the vehicle and on which computers in your cluster is this simulation happening. This can be integrated with a queuing system. There are a lot of popular queuing systems with which the manager integrates, and almost all customers use SimManager in conjunction with various different queuing systems. So SimManager is now solving the simulation, the crash input deck, and the command for the solver and all the associated parameters are also visible, including the directory on the HPC. So if the analyst is interested, he can go to that directory and look at the files during the simulation or after the simulation. Once the process is complete, an input deck result and key result objects are created, and now V2 input deck shows up into my input decks widget. There are various different ways. There are various different ways available to compare these two input decks. One of those is assembly models, which shows that these two models or these two sub-assemblies have changed. Let's say the analyst wants to see compare the meshes of the two variants of the hood. Again, the same diff mechanism gets invoked, and this time analyst is going to view the differences between the meshes created. These views were pre-configured by analyst by SimManager and were made available to the analyst so that he does not have to let's say waste his time in orienting and really diving deep to find out the differences. So as you can see, just like the CAD, the differences are in the same area, and then you could use other features of the browser to the model browser to turn on and off the parts to see the areas of interest. Going back to the input deck and to the pedigree viewer, the components of the input deck are also available on the SOD or the detailed view of the input deck along with the results and key results. Before diving deep into the results of the simulation, the analyst first wants to check if the energy balance makes sense, because it's an explicit analysis. So he can use the curve compare mechanism of SimManager to use or to visualize the differences. The curve comparison tool provides a lot of mathematical operations as well. The components of the input deck can be seen in a hierarchical manner over here, so he can make sure that really the correct components and the correct variants of the components were used in assembling this input deck. And once he's satisfied with all the preconditions, he can then start diving deep into the report that was automatically created using a preset template. He can edit this particular report to add a seed or an anchor. He decides to add the previous simulation as a seed or an anchor to it, and this simulation report automatically converts into a comparison report. So here he can nicely see the differences between the fringe plots of the bumper and the hood, as well as the differences between the energy curves between both the simulations, and then he can decide based upon his analysis what he wants to do with these changes. If he's satisfied with this, maybe he will give the feedback to the designer. If not, maybe he will decide to do some more iteration. Going back to the pedigree viewer, we can see that the V2 of the hood has a derived or generated from relationship on the CAD 04.9. So logically, analyst also wants to compare these two, let's say, objects. So he wants to compare what changed between the design model and the mesh. As you can see here, the audit trail viewer will show you the differences, the relationship between the two. He can go to the search workspace and look for the models that he wants to compare by name and also by type. And there are a lot of other filtering mechanisms available to reach the data you are interested in very fast. He then puts the objects of interest to clipboard and then goes to the clipboard to invoke the comparison between the two models. So he's comparing the design model 4.9 versus the mesh model V2. And as you can see here, the only difference between the two is a hole. Probably the defeaturing was done in this case. The hole did not. The hole existed in CAD and it was ignored during the meshing. So he can immediately know what changed and what are the differences between the mesh and the source CAD.
Okay. Thanks, Darshan. So this was a very fast navigation through SimManager. You noticed, Darshan needed to be very fast to go through all the sequences. I hope you were able to follow all the steps and all the navigations he has done. The key point right here in this part of the demonstration is really to demonstrate to you the huge amount of different ways of how the analyst can really compare stuff to each other and really can make sure that what he's doing, what he's simulating, really matches up, and that he can validate, yes, these are the right models, these are the right input decks with which I have run my simulation. So now we go to the third demonstration. What we have seen right here is we have seen two designs and the associated simulation to each other. When we go to customers, however, most of the customers not just run simulations for each design stage, but they do their own modifications to the model to assess specific parts. And actually, in many situations, we are showing right here only just modifying the hood once, using a start mesh and really just importing a new variant of the mesh, which has no correspondence to the design. What we see in many customers is that customers are doing thousands of different modifications to assess the design space of a product and running those simulations. So right here, just one step right here, and this is in our eyes very important of why also the numbering schemes of the design world and the numbering of schemes of a CAE world need to be different, because what you need to do right here is as you're doing your local iterations, you need to have very clear numbering schemes for yourself to organize all those CAE iterations you will be performing. So in the next demo, what we're going to see is we're going to import a new v2_1 version of the hood. And then again, using the simulation generator, and just to repeat what you saw in the demo is, in the simulation generator, you can then configure which modules, which versions of the modules you combine together to generate the input deck and then rerun the simulation. And again, right here, also the input deck will then have a new CAE-specific numbering scheme. With that, I hand back to Darshan. Darshan, I'm going to click right here for the full screen.
Okay.
Yeah.
So this time when a user logs in, he sees a new work request, a mesh change iteration work request being assigned to him, which has got 3 steps. Again, it was created by his manager and it was assigned to him for execution. So the first thing he's going to do is he's going to import the mesh, which was created outside SimManager and is available on his server-side visible directory. In addition to selecting this directory, you notice here there is an ability to drag and drop the files if those are on your local computer. So the new mesh is in the system now, and that can be seen inside the folder associated with that task. So v2_1 of the bumper and hood meshes are available, and the analyst now wants to create v2_1 of the vehicle and perform the simulation using the simulation generator. I'm going to try and stop this. It didn't work last time, so let's see if it works now.
Darshan, I will just stop it for you. Okay?
Okay, great. Yeah.
Nope, it's not stopped. Okay, now it's stopped.
Okay, great. So I want to spend a little bit of time, just a little bit of time on simulation generator itself. It's not the focus of this this webinar, but I think it's very important to explain. What you notice here is a matrix or a row and column based view here, in which you see that there are various components of the vehicle identified as rows, and then in the simulation drop down you see that there is a load case associated with this. So this is FMVSS 208. That's the load case that is being analyzed here. This tool provides you an ability to pre-configure a lot of load cases which you can set up and iterate by simply by changing the variants of the components via the drop downs. And if you notice in the variant on the top left, you see that this variant is called neon v2_1, which denotes that it's an iteration. So what analyst did is he did not wait, or he's not looking for new version of CAD to be made available to him, but based upon his previous analysis, he wants to do some local changes very fast and try out various different options. At the same time, he wants these local changes also to be tracked and being visible in the system. So this mechanism is also available in SimManager, because CAE is mostly work in progress, and it's not only about the end state but also the data that was generated at various different steps and the relations between the stations or the let's say variants that were generated between these two steps. Alright, so v2_1 is being analyzed. So the bumper and hood v2_1 were selected in the simulation generator. Analyst then hits submit, which brings up the assemble and simulate dialog like before, in which he can change the parameters, including which report template he wants to use. The manager creates a process associated with this particular simulation, and this process communicates with the HPC and updates the status as and when the job status updates. So this process is now finished, and you can see that in created tab, the new input deck, which corresponds to v2_1, is created right here. And in the pedigree viewer, you can see that the relationship of v2_1 mesh is clearly visible with this input deck, and hence with this result, and hence with any key result or with the report. you will notice on this view that because there was a derived from relationship between the v2 and v2_1, SimManager automatically created a diff view, and that is displayed on the single object display or the detailed view of the mesh module. In addition to that, SimManager automatically extracted some mesh quality parameters. It ran a predefined mesh quality check template and various different images and some information related to the Jacobian and quality index and warpage of the elements, so on and so forth. It could be any parameter, and it could be any, let's say, off-the-shelf or custom made model quality checking tool that can be integrated with SimManager very easily. So that's the details of this mesh quality report, which are shown on the detailed view of this, let's say, hood module. Going back to the pedigree, all the curves and images and movies are available on this view like before. And let's say this time the analyst wants to take a deeper look at the part level, not at the sub-assembly level, but the hood inner. He wants to compare the changes between hood inner and hood inner v2 and hood inner v2_1. One way of comparing is by attributes, that is metadata comparison. And as you can see here, there is differences between the thickness. Maybe one version has 0.3 and another version has 0.35 as the thickness. SimManager can also provide you a comparison view of the files associated, so you can see the same difference in the text format, in text compare format, to make sure that the data is consistent and you are looking at right reports and right models. Also, a comparison report was generated. In addition to generating the HTML report, the manager automatically converted the report into various popular document formats like PDF, DocX, and PowerPoint, which are available here as links. Those can be downloaded and sent to colleagues via emails, or the links of the objects in the SimManager system can also be shared with the colleagues for a discussion. So that brings us towards the end of the last demonstration. And again, as Michael mentioned in the very beginning, complete traceability from design model to the report can be easily achieved using SimManager system. Over to you, Michael.
Thanks, Darshan. So I hope you saw the third part, the difference between, or kind of like how we manage both design changes, manage the data, and then within one design, managing CAE iterations of creating variants of that design to analyze specific performance aspects. And what we have not talked about in detail, because this would dive too much into details, is, as you see on this very big graph right here on the audit trail path, you see the dependencies and you see the model evolution. So if we dive more detailed into this audit trail view, you would also see that we can do evolutions of, okay, this hood model was created, derived from this hood model, from this hood model, this hood model, and then from a baseline model, which was then derived from a design model. So you can have all those traceabilities over huge amounts of steps in the system to really understand also in your system, as you're doing your micro iterations, how the models evolved as you were optimizing your components to reach maximum product performance. Good. One point which I think we need to cover right here, and please bear with me, this will just be one slide, is how do we integrate the preprocessors? What you've seen in the demonstration, you've seen two ways of integration of a preprocessor. You've seen a very manual one where files were uploaded. And really what we're seeing in SimManager is that there are different ways of integrations which are directly correlated to the process maturity and the level of automation. So if there's no real automation or it's outside of SimManager, we have a manual file import mechanism and framework. If the maturity is higher, you have a preprocessor involved, we can provide to you a preprocessor integration into SimManager so that you can from the preprocessor session log into SimManager, import and export data using the API. This is pretty much comparable to how CAD stations are integrated to PDM systems. Then as the level of automation increases and you have semi-automatic preprocessing steps where you have a script but you still have interactive points along the automation, then we have a framework called toPreprocessor which launches the preprocessor with automation scripts and controls exactly how the preprocessor is executing so that you have more governance, more control of how the preprocessing step is done. And then the highest level of automation can be of course achieved when you have a batch automation, and this is also what Darshan has shown in this demonstration. One point I do want to mention in preprocessor integration is there is not one size fits all of an integration strategy. We realize that we need to provide in any successful projects all 4 levels of integrations and the mechanisms for those 4 integrations. And these 4 mechanisms are all standardly available in SimManager to be configured for your special tool landscape. Important, and you saw that in the last demonstration, is independently of how data goes into the system, independently we can create and trigger model check algorithms, and that's something as you are increasing, particularly in the level of automation, you should focus on creating more key validation and quality gate points. And that's something which can also be integrated, that is available with SimManager through the enrichment framework. Okay, with that, I come to the conclusion. What we showed you today in the presentation is, one, that we believe you need to have you have to have the design management of design models and CAE models decoupled. That you need to have numbering and versioning schemes which are different for design than for the CAE model. This becomes even more important if you have multiple disciplines in the system where you have CFD model variants, crash model variants, etc., etc. And it's the audits trail, it's the pedigree tracking which links together the design space with the CAE space. The second point which we see is very important is also that the analyst can review the data and can very fast perform comparison of any artifact with any artifact, which makes sense of course, and that there are different comparison mechanisms which need to be implemented. You need to be able to compare on assembly structure level, on metadata level, you need to compare on 3D level, has a geometry change, and has something changed in the input deck in the files. Really, we need to realize in the CAE world you need to go down to file level, and sometimes it's important to just look at the files and see has something changed, yes or no. Consistent model check is important, and then the need of traceability not only relates between CAE models and design, but goes all the way to the report and back and forth. So you cannot build a model management system for CAE in isolation of a simulation results management system. They need to be linked together. Overall, something which is actually optional on top is to really then govern your organization, your processes through a system like work request. Specifically, if you have geographically distributed teams or suppliers involved. And just as the last point, everything you saw today are standard out-of-the-box capabilities of SimManager, and if you are interested, please contact us. We can definitely provide you with a more in-depth demonstration and workshop so that you can get a better understanding of all the aspects which we have just highlighted to you, the tip of the iceberg today in this webinar. And with that, I want to end and thank you for your patience and listening into this webinar. Thanks. And I open it to questions.